Welcome back everyone. In this lesson, we are going to begin scripting our AI. Now, the way this is going to work is it's going to work in two parts. We're going to have two main different systems that are working. The first one is going to be our AI controller. Now, the AI controller is basically going to be a script which will manage the movement in real time of our AI. So basically, we give it a move direction and it will basically move us along the surface. It will detect things such as the distance to the player. It will apply gravity to us. And it's basically going to be a overall controlling script, okay? But this isn't where the logic behind the AI is going to be, okay? This is not where we are going to wander around, where we're going to flee if the player gets too close. That is all going to be managed on our state machine scripts, okay? So, in fact, without the state machine, the AI controller is not really going to work at all because it's not going to have the ability to really do anything without anything else telling it what to do. Okay, so this will make more sense once we actually start creating it. So I'm going to select our AI node here. We're going to create a new script here, and we are going to call this one AI controller. Let's create that. You will notice that since we are creating it on a character body 3D node, it's going to generate all of this code here automatically for us, but we are just going to select it all and delete it. Okay. Now, the first thing we need to do is give this a class name, because if we want to access this script from outside and modify its properties and functions, it's a good idea to give it a class name. So class underscore name, and then we'll call this one AI controller, pretty much the same as our script. Then what we want to do is we want to basically extend from character body 3D, okay? So we have access to those functions and variables such as our velocity. Now, the next thing we need to do is create some variables. So first of all, we're going to export a variable called walk speed. It's going to be of type float, and we'll make it 1 by default. Now, the export tag here basically makes it so that we can modify the property here inside of the inspector, because different AI controllers might want to have different walk speeds. We are also going to have an export variable for our run speed, okay? So this means that we are going to have the ability to basically have different speeds for our AIs, okay? So one state, they might be walking around, then let's say they want to chase after the player. Well, in that case, they would run instead of walk. We're going to then have a variable for is running of type bool. We'll make that false by default, okay? We then want a variable for is stopped, and this is also going to be a boolean equal to false, and this is basically going to be a way of us overriding our movement. So let's just say we are in a state and we all of a sudden want to stop the AI. Well, we just set this to true and the AI will stop moving, no matter if it still has a navigation path it needs to complete. We're then going to have another variable for look at player, of course, a boolean again, equal to false. And the reason for this is because our AI is going to have the ability to look in the direction it is moving or look in the direction of the player. If it's just wandering around the world, we don't want it to be locking eyes with the player the entire time, but when it is eventually chasing after us or pursuing us, we then want it to look at us, okay? So that is what that variable is going to control. We then want a variable for our move direction, which is going to be of type vector3. And this is pretty much just going to be a vector direction pointing in the direction of where we are moving towards. So if we are following a path, then it's going to be pointing in the direction of the next waypoint. If it's chasing after the player, it's going to be pointing towards us. We also then want another variable for our target Y rotation of type float. And this is for when we are rotating the AI. We don't want it to sort of snap to whatever direction it's looking. Rather, we are going to have it smoothly transition its rotation. And this is just a variable to keep track of which direction we want to eventually be looking at. Okay. And then next up, we are going to have a couple properties here. Not a couple properties, a couple nodes that we need to access or settings that we need to access. So we're going to use the onReady tag to basically mean that we want these to be set when the node is initialized. So the first one is going to be our agent of type navigation agent 3D, and this is going to be equal to get node our navigation agent 3D, okay? Because of course we want access to this in order to generate a path on the nav mesh. The next one is going to be our gravity. Now our gravity is going to be of type float, and this is just going to be set to whatever the existing gravity is for our project. Now, if we go up to project settings, and then if we go down here on the left, if we go down to where we have physics 3D, you'll see we have a default gravity of 9.8. And we can access that variable by going project settings, okay, .get underscore setting, and the setting we want to get is going to be physics /3D /default underscore gravity, okay? And that's going to get that default gravity variable and assign it to this one right here. And then finally, we also want to get our player. So on ready variable player equals get tree. Okay, so we're getting basically our current scene root node. Okay, so we're basically getting the entire scene tree for our nodes. We then want to get a list of all of the nodes inside of the player group. So get nodes in group player. Now that is why we set that player group to our player node before, for this reason here. So we are finding all of the nodes of type player in our scene, but we don't want to get all of them, we only want to get one of them, okay? So when working with this, it is important that you really only have one node tagged as the player group, because we are going to get the first element of this array by going square bracket, 0, square bracket. So this pretty much here is going to find the player. Now, one more variable, and that is going to be our player distance of type float, okay? And this is going to be set later on. So that is pretty much all the variables we need for this script right here. Now let's create the functions, okay? We are really only going to have 3 functions, but we are going to have a bit of code. We're not going to fill in the functions just yet, we're just going to lay them out. So the first one is going to be our process function right here. Now, the process function, this of course gets called every single frame, and in here we aren't actually going to do much but calculate the distance from us to the player. And in fact, we can actually do that right now because it's going to be such a short function. So we're going to go if player, and then we're going to go player distance equals position, so our current position, dot distance to the player dot position. Okay, so that is going to calculate how far away the player is. Now, the reason why we are going if player is because we don't want to try and calculate this if our player is null or we are unable to find it. Otherwise, that's going to result in errors. To make this a bit clear, we can actually go if player doesn't equal null. Okay, I think that will be a bit clearer in the code here. Now, the other functions we are going to create the physics process function. Now, the physics process function, this is similar to process, but this gets called at a fixed time rate. I believe at around 50 times per second, 50 or 60 times per second, this gets called. And this is pretty much where you do all of your physics calculations, such as assigning velocities and any other forces that you want to affect physics objects. We are then going to have one more function, and this is going to be called function move to position. Now, this move to position function is going to have 2 parameters. It's going to have a to position of type vector3 and an adjust position of type bool, which will equal to true by default, okay? Now, this move to position function, we'll get into more detail in the next lesson, but for now, that is pretty much our script done, and in the next lesson, we are going to begin filling in these functions here. So thanks for watching, and I'll see you all then. Welcome back, everyone. In this lesson, we are going to be continuing on with our AI controller script right here, starting off with our physics process function. Now, the way this whole script is going to work is it's not really going to do anything on its own, okay? You can think of it as a controller that requires an input in order to work, okay? So without our state machine, which we're going to create very soon, this script isn't really going to do much, okay? It's really just going to sit there and not do anything. And it's going to reduce the amount of code that we'll actually need when we start creating our state machine system. So inside a physics process, what are we going to do? Well, pretty much what we're going to do is we are going to control our AI. The entire point of this function is to move our AI towards its target destination, okay? That's going to be the entire purpose of this function right here. Now, how are we going to do that? Well, what we can do, first of all, is we need to get our target position. Now, to do this, we're going to create a variable called target pos, and this is going to be equal to agent.get next path position. Now, what does this mean? Well, pretty much this function right here is accessing our navigation agent 3D node, and it is getting the next path position. Now, what this pretty much means, I think if I open up Paint here, it will paint a better picture for us. So with our AI agent, the way it works pretty much is we have our nav mesh, so we can have our nav mesh right here. And when we have our AI agent, so let's create our AI right here. Let's say we want to get to our target over here, okay? We have a target here, but there might be an obstacle in the way like this. Now, typically we would get our target and we would pretty much then just walk towards it. But as you can see, we are going to collide with this obstacle, and we don't want that. We want the ability for our AI agent to walk around the obstacle. Now, the way we do that is with using, of course, a navigation region 3D node, which generates a nav mesh. And this pretty much generates a mesh along all surfaces that we can walk while avoiding obstacles. And with our agent, we can then access that nav mesh and generate a path. So in our case, it would probably look something like this. Okay, you can see it is sort of going around the obstacle there. Let's actually make this obstacle a bit more apparent. So I'll move it up there. Okay, so it would probably look something like this. Okay, now you can see it is going around it. Now, inside of our script, you notice that I called the get next path position. So what does that mean? Well, pretty much when we generate ourselves a path like this, it has a bunch of path positions, okay? So for example, we'll have one at the start, it will have one at the end, and it will have one at every single time we are turning a corner. So it might have one here as well, okay? So you can see there are 3 points it needs to go to in order to reach the end. So now what we need to do is figure out how we are going to move towards this target position. And for this, we are going to need a move direction, okay? So we'll create a variable called move direction, and this is going to be equal to our position dot direction to the target position, okay? So we are now calculating a direction vector. Now with this direction vector, we do want to set this, its y to be 0, so move direction.y equals 0. The reason why is because if our target is up on a hill, we don't really want the enemy to start moving up in the air, okay? We want them to sort of have a flat move direction vector, as this is what we then feed into the character body 3D. We then also need to go move direction equals move direction dot normalized, okay? Because we then, of course, want to renormalize it so that it has a magnitude of 1. And this will allow us to multiply it by move speed so we can adjust that as we wish. Now, once we do that, we want to basically make it so that if our agent has finished its navigation or the isStopped variable is true, then we don't want to be moving anywhere. So for this, we are going to go if agent.isNavigation finished or is stopped, then move direction is going to be equal to vector3.0. So pretty much the reason we're doing this is because when we reach the end of our target, or when we reach the end of our path, we don't want them to keep moving off in that same direction. And otherwise, if we have the isStopped variable set to true, we don't want them to keep moving, okay? We want them to stop. So that is why we are then setting our move direction to be 0. Now, what we then need to do is we need to determine what our current speed is. So we'll create a variable for current speed, and we'll set this to be walk speed by default here. Or we can then go if we are is running. So if this AI is running, then our current speed is going to be equal to run speed, okay? Then what we can do is we can finally set our velocity. Now, we can go velocity, and this is a variable that we can access. So we'll go velocity.x equals move direction.x times current speed. And we'll do the same thing for our z-axis as well. Now, the reason why we are not doing this for our y is because we don't really need to move along our y-axis, okay? That is going to be controlled by gravity, which we're going to do in just a second. Now, this velocity vector that we are accessing here isn't a variable that we have up here, but rather it is a variable that is inside of the character body 3D node, which we are extending from, okay? And that then is going to allow us to move. But in order to move, we then need to call the move and slide function, which is again built into our character body 3D. And this is basically going to apply the velocity to our AI and move us along surfaces, allow us to collide, allow us to slide, as it says, okay? So what we can do is press play, and as you can see, nothing is happening, of course, because like I said, the AI controller is not really going to do anything on its own. But what we can do is if we go into 3D here and raise it up in the air a bit, press play, you can see that it is staying there. We don't want that, okay? If our AI walks off a ledge, we want it to fall to the ground. So to do that, we can apply gravity. And to apply gravity, we're going to go to the top of our script here, to the top of the function, I mean, and we're going to go if not is on floor. The is on floor function returns true or false for whether or not we are standing currently on the floor. And this again is built into the character body 3D. All we are going to do is go velocity.y minus equals gravity times delta. Okay, so this here is pretty much just going to pull us down to the ground. Now, if you press play, you can see, whoops, oh, we missed it. Let's press play again and have a look at that. There we go. You can see the AI is going to fall to the ground nicely. Okay, so we have gravity, we have the ability to move. Now we need to set it up so that our AI can rotate to face its target, okay? So here what we're going to do is we are going to go, if they are wanting to look at the player, so for example, if look at player, then what we're going to do is we are going to create a variable for player direction, which is just going to equal to our player.position minus our current position. And we are then going to set our target Y rotation to be equal to atan2. We're going to give it our player direction.x and our player direction.z. Now this little function here, this is just a mathematic formula which basically takes in a direction and converts it to an angle. Then what we can do is we can go elif, okay, so else if we are not looking at the player, then what we want to do is go else if, velocity dot length is greater than 0, so if we are moving, then we want to set our target Y rotation to be our current velocity. So atan2 velocity.x and velocity.z, okay? So if we're looking at the player, we're going to rotate towards the player. If we're not, then we are just going to rotate towards our current velocity. And then what we can do is we can then go rotation.y equals lerp angle, and this is going to be our current rotation.y. We're going to rotate towards our target Y rotation at a rate of 0.1. So pretty much this is then going to smoothly rotate us towards our angle. Now, if you press play, you will notice that nothing does happen because we don't actually have the look at player variable set to true. So if we go up here to the top and we go to look at player, if we set this to true, press play, you'll notice that our AI is now looking at us as we move around them, which is really nice. Okay, so there we go. Now, in the next lesson, we are going to be filling in the move to position function and finishing off our AI controller. So thanks for watching, and I'll see you all then. Welcome back, everyone. In this lesson, we are going to finish off our AI controller script by filling in the move to position function. Now, the move to position function has two parameters. It has a to position as a vector 3 and an adjust position as a boolean, which we are setting to true by default. So this basically means adjust position is going to be an automatic an optional parameter. So we don't have to fill this in when calling the function. Now, let's have a look at what these are and why we're doing that. So pretty much the move to position function is going to be called whenever we want to move our AI towards a certain position. This might be if it's wandering around, we might choose a random location in the world and go, okay, move over here. That's when we'll call this function. Or if we are chasing after the player, we will give it the player's position, okay? So first of all, what we're going to do on here is we need to make sure that we do have our navigation agent node assigned. So here we'll just go if not agent. So if our agent doesn't exist, then we'll go agent equals get node, and we'll get our navigation agent 3D, okay? Just so we don't run into any potential errors. Now, what we're going to do here is we're then going to set is stopped to be equal to false, because if we are stopped and then we want to move to a position, we don't want to be stopped anymore. So we'll set is stopped to be equal to false. What we'll then do is we are going to go if adjust position. So this adjust position parameter, what does this mean? Well, basically, when we want to generate a path towards a certain location in the world, we need to give it a position in that world. Now, what that will do is that will, of course, then set a target and it will then generate a path to it. But what we want to do in many circumstances is snap that to position to the closest point on the nav mesh. Okay, so let's have a look at what I mean by adjust position. Well, let's just say we have a little terrain here as green, we have our player as, or we have our AI as the red thing, and this little orange is our target. That's where we want to go. So let's say we have our AI here and we want to choose a random position around us, okay? Anywhere along this line here. So let's just say, okay, we want to go here. So then that means that we want to then pretty much move up here. But we have set our target position, our to position, to be below here because, we don't know, the elevation of the terrain at all. So we're just picking a random position to our left or to our right. So what this is going to do is it's going to generate a path that looks a bit like this here. And it's going to stop here. Now, the reason why is because it's basically moving towards this target position right here. And this is the closest point, okay? So what we want to do instead is we want to make it so that our to position is going to snap to the nav mesh. And the way we can do that is by calling a little function, and that is then basically going to snap it up here. So then when we generate our path, it is going to look something like this, okay, basically the way we want it. Now, you may be thinking, okay, that's great, but why is it an optional thing? Why is adjust position something we can choose rather than just something that always happens? Well, the reason why is because doing this can be quite a expensive calculation, so if we don't need to do that, then we don't want to do it. For example, if this orange circle here is our player, then we just need to give it its player's position, okay, which is already going to be pretty much on the nav mesh, and then we can calculate that path easily, okay? The player's position isn't going to be somewhere off random that we need to snap to the nav mesh. Okay, so that is basically the role of the adjust position parameter. So what we're going to do is if we want to adjust the position, then we need to do a few things. First of all, we need to get a variable here called map, and this is going to be equal to get world 3D dot navigation map. This is basically getting the nav mesh of our current scene. Then what we need to do is create a variable called adjusted position, and this is going to be equal to the navigation server 3D dot map underscore get closest point, and then we'll give it our map and our to position. So pretty much this is just going to snap our position to the closest point on our nav mesh, okay? And like I said before, this calculation can be expensive, so that is why it is an optional thing we are having. And then finally, we'll go agent.targetPosition equals adjusted position, okay? And that is going to generate ourselves a path towards that position, and then the code inside of physics process is going to run, okay? It's going to get the next path position, we're going to calculate a direction towards it, and then we're going to move towards it, okay? Now, otherwise, if we don't want to adjust the position, then we are just going to do this. We're just going to go agent.targetPosition equals to position, okay? So we're just going to give it our direct position like so. So pretty much if we are moving somewhere along our terrain, we're going to have adjust position to be true because we want to snap it to the terrain. Otherwise, if we are moving towards another agent or towards the player, then we are just going to give it the player's position. And we don't need to worry about adjusting the position at all because the player is standing on the terrain, which basically means the player's feet are going to be in line with the nav mesh already. So we don't need to do the expensive calculation of adjusting that position automatically. Okay, so that is our AI controller script set up and ready to go. Let's just go through again real quick in case some things are a bit confusing. So here inside of the process function, which gets called every frame, we are basically calculating the distance between the AI and the player, okay? Because this might be something you need in one of your states. For example, if we get within 5 meters of the player, we might want to run away. Okay, so that is why we need to keep track of player distance so we can access it later on. Then down here in physics process, which gets called every fixed time rate, what we are doing is we are first of all applying gravity if we are in the air. We are then calculating the position towards our next target position along the nav mesh. We're then calculating our direction towards that position. We are normalizing it so that we have no upwards direction, rather this is just a left, right, forward and back direction. That's what we're doing here by setting the y to 0 and normalizing it again. Then what we're doing is we are checking to see, okay, if our navigation is finished, so if we have reached our target position, or if we are stopped, then we want to have no move direction, so we are setting that to be 0. Then down here, we are calculating our current speed. By default, it's walk speed, but if we are running, we are setting that to be our run speed. And then down here, we are assigning our velocity vector to be our move direction multiplied by our current speed, okay, along the X and the Z axes, not the Y, because the Y is controlled by this right here, applying gravity. And then we are calling the move and slide function, which will basically take that velocity and apply it to the AI and move them along the ground. Then down here, what we are doing is we are going, okay, if we are looking at the player, or if we want to look at the player, we first of all calculate the direction towards the player, and then we set our target Y rotation to basically be in line with the player. Now, otherwise, if we are not looking at the player, and if our velocity is greater than 0, so if we are moving and we are not looking at the player, then our target Y rotation is going to be facing our current velocity. And then down here, we are calling rotation to Y equals lerp angle, and lerp angle, basically it takes in a current, which is our current rotation, it takes a target, which is our target Y rotation, and it basically moves our current to our target over a certain amount of time right here. And this is what allows us to smoothly rotate our AI towards its facing direction. Now, down here in the move to position function, what we are doing is we are checking first of all to see if we don't have an agent for some reason, then get the agent. Then we are setting is stop to equal false because we want to start moving again. If we want to adjust the given position, then what we are doing is we are basically accessing our navigation map, and we are then calculating the closest point on that nav mesh based on our to position, and then we are setting our agent's target position to equal that so that it will begin moving towards it along its generated path. Otherwise, if we don't want to adjust our position, we are just setting it raw like this, okay? And whenever we do assign a target position here, that is when the automatic generation of our path will occur, okay? We don't have to go in and manually create our path. It's done automatically when we assign the target position. So that is our AI controller script, and like I said, it doesn't really do much right now because the AI controller doesn't do anything on its own apart from looking at the player or not. So in the next lesson, we are going to begin working on our state machine, which is going to allow us to start assigning logic to our AI and giving it different behaviors that it can do. So thanks for watching, and I'll see you all then in the next lesson.